Previously, we had a look at our AI-powered MERN Stack project's overview, where I gave an introduction about the project and the full-fledged tech stack we were using, followed by the completed project demo. Today, we are going to take a step back and discuss something equally important, which is the project architecture. This is where I will address some key areas and issues such as how I planned out this project and how important is this project architecture for a full stack project, and how does our tech stack actually fall into place in this architecture. How will our front end communicate with our backend API? And lastly, how we will be designing our database for this entire project. With so many hows to figure out, let's start with the first one. So how did I plan out this project? Now, understanding the architecture is what separates a quick prototype from a scalable professional project. When I started planning this project, my main goal was to keep things simple. So I broke down this app into three clear phases. Phase 1. We focus first on the core features of this application, like setting up the project setup on both the front end and the back end, the homepage component on the front end, then the user authentication part, as well as the user dashboard pages, and then global error handling, as well as transaction and budgets on the back end. Now, this way, I could make sure the foundation was solid before layering in any advanced functionality. And then phase 2. This is where we finish off some advanced features of this application, like we complete the transaction page as well as the budget page on our front end, and then also we will be implementing the most important part of this project, which is the receipt recognition system, basically the AI integration part. And then lastly, we will be implementing the notification system on both the front end as well as the back end. And then lastly, we have the final phase, which is phase 3. In this, we will be connecting our front end with our back end systems, which means the pages we initially created, like the dashboard page, transactions page, the budgets page, and the notification page, all of that from the front end will be connected to our back end with the help of global state management. And upon that, our entire project will come to a conclusion. So, where did I get this idea from? Now, I was in a team of 6 people where we were expected to come up with a real life problem that requires a real life solution. Now, this idea came from a group discussion of all 6 of us where we figured out one common pain point. Manual finance tracking is boring and it is close to error prone as well. So we thought, what if we could use AI in some way to help us figure this out? And the best solution we came across was to automate receipt entry so that it keeps users disciplined with proactive alerts as well. And well, that is how the concept of an AI powered financial tracking application was born. And now let's talk about the MVP. What is MVP? MVP stands for Minimum Viable Product. And MVP is the simplest version of your project that delivers value. For this application, the MVP was very simple. The users can browse our web pages, they can log into our system, add transactions, create budgets, view notifications, and once that was working, we will be adding the AI receipt scanning as well as some advanced charts and functionalities. And to anyone who is watching this video, always remember, start small and then build up. This way, you won't feel overwhelmed or confused when you are working with too many features to implement and sometimes end up doing nothing instead. And I also need to mention something else that is important, which is the SRS, short for Software Requirements Specification document. Now, I have created an SRS for this project. It is basically used to document features, workflows, and timelines. But I won't go into detail or show it here since that would take way more time and it is kind of out of scope here. But if you're working on a team, just remember that having an SRS helps keep the team aligned and it avoids confusions a lot later down the line. This brings us to the next question, which is why is this architecture important so much? Well, an architecture defines how all the moving parts of your application fit together inside a single project. Because without a clear architecture, you risk building features that don't scale, or to make matters worse, features that break when you add new ones. A good architecture is like a blueprint. It guides the development and ensures long-term stability. Now let's take a look at our MERN Stack project's app architecture. First, let's break down how each part of the system works together, from the user all the way to the database. At the top left of the stack, we have the user, which is here. and that is you or anyone who is interacting with the application. The user will send a request like clicking a button or submitting a form, and this user will expect a response back, like seeing updated data or a confirmation message. Next, we have this block which we will be calling as the front end. This is also known as the client application. So this is built using HTML, CSS, JavaScript, as well as, and the most important part, React.js. Now, React will help us build dynamic user interfaces that respond quickly to user actions, which makes our application feel smooth and interactive. Now, when the front end needs to fetch some type of data or update some type of data, it goes to the backend. So how does it go? It goes by sending a request to the backend, which is in this case our Node.js server. And in here we will be using Express, which is a lightweight framework that makes it so much easier to define routes and handle HTTP requests for this application. I'll explain what all these technical terms are once we start building our backend API. And from there, for database operations, since we need to store data in our application, we will be using what a service here called Mongoose, which simplifies working with MongoDB, which is our database, by giving us a schema-based solution. And finally, at the bottom of the stack, or at the very last, we have our database, which is MongoDB. This is where we have all our data that is present in our application. So it can contain information like users information, categories, transactions, budgets, receipts, alerts, and pretty much or whatever our app needs to store data. And MongoDB is a NoSQL database, means it stores data in a flexible JSON-like document. Now you might be asking, what is a JSON document? Well, let me show you. Now this right here is an example for a JSON object. And this looks very similar to a JavaScript object where it has key value pairs. So in this example, this is just a transaction example that should usually occur when you make a transaction. Like in this case, the sender's name is Alice Johnson and she is sending a transaction to a person called Bob Smith, and the amount would be 250. So at the very top we have the transaction ID, which uniquely identifies this transaction has happened, followed by the date and then the amount, then the currency, which is in US dollars, and then a status that says completed, and just some other information like the payment method, the sender, the receiver with their names, and then lastly a note that says what this payment was done for. So this is just some basic example. This is what a JSON document or a JSON object looks like. Now let's talk about how our front end is gonna communicate with our backend, because that is the most important part of this application, right? So the front end would communicate with our backend with the help of RESTful API. Now what is a RESTful API? Our entire backend that we will be building is a REST API. More on that later. Now let's first focus on how this process will be working, and then we'll explain each one in detail in their relevant sections as we get to that video. So the data will flow this way. The user interacts with the database by sending an HTTP request. Let's say the user is making a new transaction. He or she sends a request and that request goes to the front end, which is the client application. And then this client application will forward that HTTP request to the backend, which is our Node.js server. And then Node.js will use Mongoose in here to communicate with our backend database, which is MongoDB in here. Since we are creating a transaction, we will be sending a post request to the backend, and then what the backend would do, it will create transaction for us in that relevant user's name, and then once that data is created, it will be sent back to the backend as a response. So from here all the way to here, it is what you call a request. This all is, and then from the database what you get here, this is a response. You get that response, the response goes to the backend, and then from the backend it sends that request back to the front end, which is here, and then that response goes here as a response to the user in the end. Now remember that this request response cycle is the backbone of how our entire application is gonna work. Now you might be thinking, I didn't explain what these two things actually are. Well, I'll just give you a high level idea about it, and then in later sections we will discuss in detail how they both will actually work. Now, when a user sends a receipt, let's say the whole point of this application is to read bills, right? Let's say the user is sending some type of a bill to our application. Now, what do we need to do? We take that bill, let's say it comes as a request, we take that bill to the front end, we send it to the back end, and before we actually save it on our database, we do some additional parts here. First, that bill is stored as a receipt image inside the Amazon S3 bucket. Just think of it as another database, but that is in the cloud. It is not directly linked or connected to our application. It is a third-party service. Just remember it like that. So we send an image as a post request to the Amazon S3 and it will store those receipts. And then what would happen is once that part is done, the backend will again send another request to fetch that image from the Amazon S3 bucket. So it comes here, it goes back, fetches the image, which is the receipt image. In this case, the receipt is the bill. The backend will fetch that image back. Now we have information about this receipt. It's stored here, but we have access to that receipt. Now what do? We send that receipt to Gemini API. And how do we send it? We will be sending it to parse that image. And by parsing, I mean extracting text from those images. That's what parsing actually means. And that process is called OCR. OCR stands for Optical Character Recognition. And what does Gemini API do? It performs this OCR, which is extracting the data out of that image. It extracts all the important data out of that image. And then Gemini API will return us a draft transaction as a JSON response. That is why it's just shown here as get JSON. We just get the JSON response from Gemini API to our backend. So what will happen now? Now the receipt data is saved on our backend. So the receipts data is stored here on the backend as a draft transaction, but the actual receipt, the image, is stored here. We only store here the draft transaction that goes from this cycle, comes back from here, and then goes here, and then comes back from here, and then we save that part into our database. And then what we do here is we send that draft transaction back to the front end. The user can then edit that transaction, and if he, by the way, we send a draft transaction here and it gets sent back as a response to the user. If the user wants to save that as a transaction, we just repeat that same steps we used to create a transaction. User makes a request here. He says, okay, I have checked all these, all this is good. Let's make this a transaction. So that request goes from the client tab to the Node.js server, back to the database, and then the data gets saved. It sends a response back saying your data has been saved to the backend. The backend sends that data to the front end, and then we get to the user. Alright, now that last part didn't make sense to you? Don't worry, because we will be revisiting this in phase 2 of our production. And by then, you will fully understand what this entirely means. Now we need to think about how our tech stack will fall into place into this system architecture, right? So how this fits together is you see React here, right? Now our tech stack is MERN Stack. So we need to first look at React.js. React.js will handle the user interface on the front end, and then Express.js will as well as Node.js will power the backend for us, this part, and then MongoDB will store all that data in the database. And that is pretty much it. We have also discussed some other technologies like Clark for user authentication. So that actually works between the front end and the back end in like a separate block like these two guys here. I'll explain how that works in the later videos. And then lastly, we will be deploying this in Netlify. The front end will be deployed on Netlify and the backend will be hosted on Render, which is a hosting site for backend APIs. Now what you need to remember is each piece that you see here, all these things play a very crucial and important role in this architecture, and together they will form a complete system. And now let's talk about our database design. I'll just show the ERD here for you guys to get an idea of how the database is structured. So for the database, we have used MongoDB like I explained earlier. We have designed collections for users, transactions, budgets, categories, and notifications. Now each collection is structured to make queries efficient. For example, we can say like transactions are linked to users, budgets track spending categories, notifications are tied to some type of thresholds like, getting alerts for like 50% of a budget limit being touched or 90% or reaching the maximum limit of a budget and so on. So now you might be thinking, why is a database design so important? It is the most important part of an application. Why? Because a well-designed database makes our app really fast and reliable, and without a database there is no data, so we definitely need one. So that is the architecture of our AI powered MERN Stack project. From idea to the MVP, from the tech stack to the database design, I have explained everything very clearly. And if you have any doubts or any issues, just make sure to drop a comment. Make sure to subscribe to this channel and hit the bell icon. Why? Because in the upcoming videos, we are going to be doing a lot of great things on this application. And on the next video, we'll roll up our sleeves and start building the initial project structure for this application on both the front end and the back end. See you on the next one. Bye bye.